and welcome to another installment of Remi-Rix the Science Chick. I'm your host, Remi-Rix the Science Chick. Today's webisode is about chemical polarity. I was just chilling in my basement building a molecule out of polystyrene balls and decided to give it a little extra shine with this stuff. And then this happened. The question is, why? Molecules are sort of like batteries. They have a slightly positive end and a slightly negative end. This has to do with the distribution of electrons around the molecule. One of the main factors affecting chemical polarity is electronegativity. Electronegativity is an atom's tendency to attract electrons. It increases as you move towards fluorine on the periodic table. The difference in electronegativity will determine whether the bond is polar or nonpolar, or polar covalent. Let's take a look. Let's take a look at sodium chloride, table salt. Chlorine is much more electronegative than sodium, so chlorine will attract all of the electrons and steal them all away from this evil sodium. So the bond is ionic, in other words, very polar. Now let's take a look at carbon monoxide. Oxygen is more electronegative than carbon, but not enough for all of the electrons to be completely pulled over. So the electron cloud looks something like this. The bond is polar covalent. Now let's take a look at the bond between two carbons. The electronegativity difference is 0, so the bond is nonpolar. The electrons are shared equally. The electron cloud looks something like that. The other factor affecting chemical polarity is the shape of the molecule. Let's look at H2O, water. The molecules look something like this. Oxygen is more electronegative than hydrogen, so the electrons will be attracted inward to the oxygen. So oxygen will have a slightly negative end and two slightly positive ends. That's a delta, by the way. The electrons are attracted inwards to the oxygen. So there's a net dipole going up like that. Now let's take a look at methane. Fart gas! It looks a little something like this. Carbon is more electronegative than hydrogen, so the electrons are attracted inward to the carbon. Now I know what you're thinking. Polar molecule? Not so fast. Because the hydrogens are evenly spaced around the carbon, the electrons are attracted equally inward to the carbon, so they cancel each other out. So it is in fact non-polar. Rule: likes dissolve likes. After some research, I found out that polystyrene is non-polar. So there must be something in the gloss that's also non-polar. The gloss contains a toluene solvent and a butane propellant. Both are non-polar. And now I know what happened to my balls. Shouldn't have said that. So either the toluene solvent or the butane propellant dissolved the non-polar bonds in my balls. I really need to stop saying things like that. So I hope you enjoyed this webisode of Remi-Rix the Science Chick. I'm your host, Remi-Rix the Science Chick, saying go forth and do science. Ta-da! And be sure to check out the extra credit video in which I dissolve polystyrene balls with the power of spray paint. This is a scale model of a caffeine molecule. Be jealous.